All right, measurement, bearings and radial surveys. So bearings are the direction of one object from another. So there are two types of bearings. There are compass bearings and true bearings. So compass bearings are these ones that you can see on your phone. You have a phone compass, you can point it. That is telling me that that is exact north right there. So you've got a compass bearing, and then we've got true bearings. These are not bearings that you see on your phone. Compass bearings use the four directions of the compass, so north, east, south, and west. And they also use northeast, southeast, southwest, and northwest. They're indicated by those red dotted lines. Okay, so when you're using compass bearings, you will either state an angle as being north or south, and then it's either going to be the number of degrees towards east or west. So when you're doing it, you're only ever working from north towards east or south towards east, or then north towards west or south towards west. You never work from west to south or from east to north. You're always working either it's north or south, and then you're going into either east or west. All right, so what are each of these angles using compass bearings? How would we work these out? Well, this one here, this pink line, is going to be definitely north, and it looks like it is, if that is 30 degrees, that this must be 60 degrees away from the east. So it'll be north, 60 degrees east, and then this line is definitely south, and it is, for this one we would do 30 degrees because it's 30 degrees away from east. And then this one is going to be, 60. I take that all back. Why do I keep second guessing myself? This one is 24 degrees away from the south line. So we would do 24 degrees west. And we've got those there. North 60 east and south 24 west. Remember, you're always using the angle between the vertical line, so don't worry about using this angle in here. All right, we're now going to take a look at some more examples together. Amanda hiked 67 kilometers from her car on a bearing of south 64 east. How far did she travel due east to the nearest kilometer? Okay, she traveled south 64 east, which is in this direction. So this is her car. We'll draw Amanda's little car. There's her little car. We'll give it a little A. And she traveled 67 kilometers on a bearing of south 64 east. So we'll draw a compass. This is south. This is east. And we know she went 48 degrees, so just over 45 degrees that way. So this must be 48 degrees. She traveled that direction. And we know this is a 67 kilometer line. How far did she travel due east to the nearest kilometer? So this is actually a trigonometry question. What we need to do is draw a triangle. This is 90 degrees. This is 48, which we know that all the angles of a triangle add up to 180 internally. So we do 180 minus 90 minus 48. This other angle is going to be 42. And we know that this is 67 kilometers. So we know that this is the due east line that we're looking for, right? So this is our kind of like piece of information that we're searching for. Let me just try and grab, there we go. All right, so that's the question that we're looking for here. Let's see, do I have a better diagram? No. Okay, so what we'll do is, now that we know that, we really just need to use one of our sin, cos, or tan ratios to work it out. So this is our hypotenuse, this is our opposite, and this is our adjacent. And we're looking for our adjacent, and we have our hypotenuse, so we can use cos. So our angle cos is going to be cos 90, and it's going to be our adjacent, which is our x, over our hypotenuse. So we'll have a look. Cos 90 times 67. Oh, hang on. No, that's incorrect. I used the wrong angle. Where is our angle? 48 is our opposite angle. take it back, cos 48. Actually, I should just have this on my slides. There we go, cos 48 times 67, and we're going to get 44.83, which is equal to 45 kilometers. So again, it was here. This angle here is opposite this, and this is opposite that. Sorry, not our 90, our 48, and that gives us 45 kilometers. So the thing with bearings is it often turns into a trig ratio question, even though it started as one length and one distance, right? Like there wasn't even, the angle is like buried in the bearing, right? Like it's not even, doesn't even look like a trig question to someone who's used to very like normal trig questions. So that's why it's important to try and understand the connections that each of your topics have with one another, because this is a question where it's like, oh yes, I'm doing a bearings question, but I need to bring back my trig knowledge, which luckily we teach this with trig. Okay, so let's have a look at true bearings. True bearings measure the size of the angle clockwise from north. So they're always 3 digits. For example, we've got this one, which is south 14 west as a compass bearing. But as a true bearing, it's 194 degrees T, or true, because this is 180 plus 14. So 180 plus 14 is equal to 194 degrees true. So you always add the T at the end, and there's no direction, no north, south, east, west. We'll have a look at these two. So this one would just be, you always do 3 digits, 23 degrees true, like that. And this one would be 90 plus, this is 47, which means that this must be 43. Yeah, that must be 43. So 90 plus 43 is 133 degrees true. Okay, this is from the 2014 HSC General 2 paper. The following information is given about the locations of 3 towns, X, Y, and Z. X is due east of Z. X is on a bearing of 145 degrees from Y, and Y is on a bearing of 60 degrees from Z. Which diagram best represents this information? So let's start by ticking off each of our pieces of information. X is due east of Z means that it must go ZX. So we know that this and this are not correct. X is on a bearing of 145 degrees from Y, means that this angle must be 145 degrees. So let's see. Either of those could be 145. Now we could work out from there, but let's actually go to our last piece of information just to confirm. Y is on a bearing of 60 degrees from Z. This is Y. Z, we've got, okay, 60 degrees, 60 degrees. So we have to work it out from this piece of information. Now, if X is on a bearing of 145 degrees from Y, it means that this angle has to be 145. Now, if this one's 145 and this one is 120 because it's the internal opposite to 60, making our 180, it cannot be A. So therefore, C has to be our answer. Okay, here's another example. A ship sails 6 kilometers from A to B on a bearing of 121 degrees. It then sails 9 kilometers to C. The size of angle ABC is 114 degrees. What is the bearing of C from B? Okay, so we've got A, B, and C. We've been told the ship sails 6 kilometers from A to B. So we would label this 6 kilometers. And it's on a bearing of 121 degrees. So this angle here is going to be on a bearing of 121. Yeah, that's 121 degrees. It then sails 9 kilometers to C. Angle ABC is 114 degrees. Okay, so that's 114 degrees. What is the bearing of C from B? So we're looking at C from B, which means we need this angle. So we know that if this is 121, these are both north lines, which means we can find out this angle here by doing 180 minus 121. So it's 59 degrees in here. So if we do 114 minus 59 degrees, we get 55 degrees. So this side must be 55 degrees, which means the bearing of C from B is 55 degrees. Find the distance AC, so we're looking for this line. We can do our cosine rule here, so C squared is equal to A squared, so C squared plus B squared minus 2 times A times B times cos C, which is 114. So once we pop that into our calculator, 6 squared plus 9 squared minus 2 times 6 times 9 times cos 114. We get 160.92, and it says to the nearest kilometer, so 161 kilometers. That is a kind of more complicated bearing and radial survey question. Okay. So, how to ace bearings. Lots of people struggle with this topic. You're not alone if you think it's that hard. Please keep practicing. Remember that true bearings always need 3 digits as well. So if the number is lower than 100, you always put a 0 in front of it. So don't do like 62 true. You got to do 062 true. Okay, and then also remember the order of compass bearings. You're doing north, south first, and then east and west. So that's bearings. We're now going to move on to radial surveys. These involve measuring angles from a center point. So specifically, you'll focus on compass radial surveys. They give you a bunch of true bearings. That's why it's super important that before you kind of tackle radial surveys, you're also comfortable with bearings. Okay, so this is a standard question. Find the size of angle APB. So you'll see we have a center point here, which is represented by the letter P. Then we have the distance to those outer points. You could even think of them as like, this is the solar system. Like this is the sun and these are all the different planets. And then you'll see we've got true bearings. So this one is 53 degrees true, 95 degrees true, so on and so forth. Find the size of angle APB is this angle. This is super simple. All we need to do is find the difference between these two angles. Now remember, this is 0 degrees here. So it's going to be the difference between 360 and 308 plus 53 degrees. So 360 minus 308 is 52 degrees. Plus 53 degrees on this side. So our final answer is going to be 105 degrees for angle APB. Okay, find the length of CD. So we're going to do this using the cosine rule. So we've got CD here. I like to draw out my own triangle because it gets a little complicated. Okay, so this one is 59 meters on this side, 42 meters on this side. We know that this angle internally must be the difference between 162 and 95. So 162 minus 95 is 67 degrees. So what we're going to want to do is find, well, the area of the triangle is half times A times B times sine C. So we can do that by using what we have here. We'll do half, we're not looking for the area, I'm reading ahead. We're looking for the length of CD. So we can just use the cosine rule. So we've got, this is going to be our, like C we'll call it. And to find an opposite side, we can do C squared equals A squared plus B squared. Sorry, we're going to jump down a line. Minus 2 times A times B times cos C, so 67. Pop all that in a calculator. And that gives me the answer, because we have to square root all of that, 57.51. Okay, so 57.51 is this direction. And actually that reminds me, back on this question, I didn't square root it. So you actually have to square root that. I take back my 161 and it's actually 12.68, nearest kilometer, so 13 kilometers. My brain's fuzzy, forgive me. Okay, there we go. The area of triangle, okay, so yeah, we've got that 2 square root, what did I write down? 57.51, okay, it's round to 5.2. And then the area of triangle APE, so we've got this triangle, where is it? APE, we have to do half times A times B times sine C. So half times A, which is 61, times B, which is 52, times sine 69. And that'll give us the answer, 1,480.66 meters squared. A lot of writing on that slide. I'm going to give you, hold on, I'll just erase all that ink and you can see those answers a little clearer now. There you go. Okay, let's have a look at another radial survey question. This diagram shows an incomplete radial survey of a block of land. Find the size of angle AOB. So AOB is this angle in here. And we can see we have 180 minus 50. So all we have to do is 180 minus 50 is equal to 130 degrees. Calculate the length of AC. Again, we have our two internal sides and our internal angle is going to be 30 plus 50. So that's going to be 80 degrees in there. And it's again the cosine rule. So C squared is going to be 375 squared plus 225 squared minus 2 plus 375 plus 225 minus 2, wait, a squared plus b squared minus 2ab, now I'm forgetting my rule, hold on. Yeah, times, not plus. Times, and then times cos 80. And once we do all of that, and square root at this time, square root, we get 402.426. So we'll do 402.43 meters for this side. Okay, here is another example. Refer to the radial survey below, find the angle EOA, find the length EA, and find the triangle EOA. Okay. Angle EOA is just going to be the difference between these two. So 334 up to 360. So 360 minus 334 is going to be 26. And then we got to do plus 38. So that internal angle is going to be 64 degrees for this one. The length of line EA, again, we do our cosine rule. So it's going to be A squared plus B squared. Minus 2 times A times B times cos C. So pop all of that in. Make sure you square root. Now answer should be 6.36. 6.36 centimeters. Find the area of triangle EOA. So it's going to be half times A times B times sine C. Remember, you need a group of information like this all on one side. And we pop that in our calculator, half. Oh my gosh, what's happening? Half times A times B times sine C. And that gives me 12.58 centimeters squared, like that. Okay, let's have a look at this example here too. Imagine that each side of the radial survey is connected to create the shape JKLM. Find the perimeter of the shape. So this involves us doing essentially 4 applications of the cosine rule to find the perimeter of this shape. And then we want to find the area. So this one's quite lengthy. To find let's kind of treat it as one big question. First, you find all the internal angles. So 360 minus 324 is 36 plus 27 is 63. So this one's 63 internally. This one is 148 minus 27. So that's going to be 121. This one's 237 minus 148. And that's going to be 89 degrees on all of these. And then the last one is 324 minus 237. And that's going to be 87 degrees, like that. So then we need to do the cosine rule to find each of these larger lines. So the first one is going to be 12 squared plus 11.78 squared minus 2 times 12 times 11.78 times cos 63. And that, once square rooted, is going to be 12.43 kilometers. The next one, again, same thing. So 11.78 squared plus 11 squared minus 2 times A, which is 11.78, times B, 11 times cos 121, square root it. This one's going to be 19.83 kilometers. The next one, so 11 squared plus 13.24 squared minus 2 times 11 times 13.24 times cos 89. And that's going to give us, once square rooted, 17.06 kilometers. And the last one, 13.24 squared plus 12 squared minus 2 times 13.4 times 12 times cos 87, square root it, and that's going to give us 0.40 kilometers. And so then we find the perimeter by adding all those together. So 17.40 plus 12.43 plus 19.83 plus 17.06 gives me 66.717. So we would do 66.72 kilometers. And then to find the area of the shape, we need to find the area of all the triangles. So the first one is going to be half times 12, so half times AB sine C. So half times 12 times 11.78 times sine 63. So the first triangle is, we'll list them out here, 62.98 kilometers squared. The second one is half times 11.78 times 11 times sine 121. So the second one is 55.54 kilometers squared. The next one is going to be half times 11 times 13.24 times cos 89. And that's going to be, oh, sorry, not cos. Hold on. Oh, okay, let's restart. Half times 11 times 13.24 times sine 89. And that is 72.81. And the final one is half times 13.24 times 12 times sine 87. And that is 79.33 kilometers squared. So we add all those together. And we get 270.66 kilometers squared. Oh, take a breath. That is how complicated these questions get. It's just doing the same thing over and over and over and over and over, and then potentially over again. Okay. This is our very last question, although no, we will not be doing this because it is that long, but do come back to it. It's just that we have one more topic to get to and we only have, how long left? 30 minutes. So I don't want to do this question and the other topic and the wrap up. Very much come back to this question on your own though. But how do you ace radial surveys? Remember that when you're looking at compass radial surveys, the angle are the positioning on the compass, not the angle, the size of one of those angles. So on this one, right, like this is not a 37-degree line. It's the difference between these two. Remember that degrees start from north and not from a prior line. They're always going north around. And radial survey questions are not easy. They take a lot of time. So please just keep attempting and trying and labeling your information and practicing. All right.